Good morning to all. I am Karthik, Assistant Professor, Mechanical Engineering Department, SNS College of Technology. In this video lecture of invariant reactions, the first video is about hypo-eutectoid steel and eutectoid steel. This video is about hyper-eutectoid steel, where this hyper-eutectoid steel, you can simply say, as its name implies, this hyper-eutectoid steel is formed after the eutectoid reaction takes place, or you can say this hyper-eutectoid steel has the carbon percentage of more than 0.8 or up to 2. Okay, more than 0.8 or more than 0.8, 0.9 or 1 up to 2. Okay, here you can easily say this hyper-eutectoid steels at the temperature of 1000 or 1100 degrees Celsius, you can see a pure formation of arsenate structure, or in the other words, you can say this microstructure is full of gamma ion or arsenate. Okay, upon cooling, you can see this arsenate grains has a grain boundary, as you already know. This during the reaction, during the cooling, you can see pro-eutectoid cementite is formed in between the grains, or particularly on the grain boundaries. Okay, so we can, as like the previous hyper-eutectoid steel, this hyper-eutectoid steel has the formation of Fe3C or cementite or iron carbide is forming on the grain boundaries. So as upon cooling, you can see this grain boundaries, the pro-eutectoid Fe3C will start to grow upon cooling. So you can see a layer is formed, or a layer is formed in between the grains of the perlite. So as we compare to the previous hyper-eutectoid steel, you can clearly say here the perlite is combined with the pro-eutectoid Fe3C. In hyper-eutectoid steel, you can see pro-eutectoid alpha. Here you can see pro-eutectoid Fe3C. So this steel is formed, has the properties of predominant properties of perlite and also cementite. So you can say it has so in hyper-eutectoid steel, you can easily say it has an alpha, a pro-eutectoid alpha and Fe3C. In hyper-eutectoid steel, you can see an alpha, an Fe3C, and pro-eutectoid Fe3C. So there will be a formation of lines, or there is a formation of pathway in between the grains, it's like a river in between the forest. Okay, so this formation of pro-eutectoid Fe3C and pro-eutectoid alpha is due to the reactions that are formed during the process, right? And when we compare to in eutectoid steel, you cannot see these types of reactions that takes place, which because in the iron carbide diagram, you can see the eutectoid reaction takes place at 0.8% of carbon, where this arsenate is completely transformed into perlite at a stretch. But when we compare to pro-eutectoid alpha and hyper-eutectoid steel and hyper-eutectoid steel, you can see the middle formation is happening. In hyper-eutectoid steel, you can see alpha plus arsenate is alpha plus gamma ion is a heterogeneous structure is taking place. But as well as in hypo-eutectoid steel, you can see gamma plus gamma ion plus Fe3 is taking place. So this makes this helps to, or this in other way, it is happening, or it is the reason for formation of this pro-eutectoid structures. Thank you.